In this video, we can discuss ninth class fourth topic lines and angles. In this topic, we can discuss lines and transversal. Before that, whatever we learned concept recall once. A line M and another one line L intersect at P. So two lines are meet at a P point. So therefore, these lines are called intersecting lines and P is called point of intersection. Here more than two lines meet at a point Q. This type of the lines are called concurrent lines. The point is called point of concurrency. Then we can discuss about the transversal. What is the transversal? If a line meets other two lines at two distinct points, then the line is called a transversal. A line M and a line N and another one line intersect remaining two lines at distinct points P and Q. The line L is called transversal. At point we get four angles and at Q also four angles 1, 2, 3, 4 and at Q 5, 6, 7, 8. If a line intersect remaining two lines at distinct points, the line is called transversal. The angles which are non-adjacent and lie on the same side of the transversal of which one is interior and other is exterior are called corresponding angles. We can discuss now pair of corresponding angles. This type of the angles are called pair of corresponding angles. So which are 1 and 5. So same side of the transversal and non-adjacent. Angle 1 is exterior, angle 5 is interior. Therefore 1 and 5 are the pair of corresponding angles. Remaining pairs 2 and 6, 3 and 7, 4 and 8. So we are getting four pair of corresponding angles are the two interior angles which are non-adjacent and either side of the transversal are called alternate interior angles. Now we can discuss alternate interior angles. Pair of alternate interior angles. So 3 and 5. So both are interior is either side of the transversal and non-adjacent angles. Therefore 3 and 5 are the pair of interior angles. And another one pair is 4 and 6. Pair of alternate interior angles, we are getting two pairs. Now another one type of the angles, the two exterior angles which are non-adjacent and either side of the transversal are called alternate exterior angles. Alternate exterior angles similar to the alternate interior angles. Pair of alternate exterior angles 2 and 8. Both are exterior and either side of the transversal and non-adjacent angles. Therefore 2 and 8 are the pair of alternate exterior angles. And 1 and 7 another one alternate exterior angles. We are getting two pairs. Interior angles on the same side of the transversal are also referred as a consecutive interior angles or co-interior angles or allied angles. We can discuss now co-interior angles. Same figure we are taking co-interior angles. The co-interior angles on the same side of the transversal interiorly. This is the transversal, same side 2 angle 3 and angle 6. Both are on the same side. That's why these are called co-interior angles. Angle 4 and angle 5 are also another one pair of the co-interior angles. Now co-exterior angles. Exterior angles on the same side of the transversal are also referred as a consecutive exterior angles or co-exterior angles or allied angles. Co-exterior angles similar to co-interior angles. Co-exterior angles, both are the same side of the transversal and both are exterior and non-adjacent angles. Therefore 1 and 8 is the one pair, and 2 and 7 also another one pair. Axiom of corresponding angles. If a transversal intersect a pair of parallel lines, then each pair of corresponding angles are equal. If a transversal intersect a pair of parallel lines, the corresponding angles are the equal. M and N are two parallel lines. L is a transversal. Intersect at M at P and N at Q. We are getting 4, 4, 8 angles. Pair of corresponding angles. Already we discussed pair of the corresponding angles 1 and 5. Therefore, angle 1 is equal to angle 5. Angle 2 is equal to angle 6. Angle 3 is equal to angle 7. And angle 4 is equal to angle 8. Theorem 1. We can prove this theorem based on the axiom whatever we learn now. If a transversal intersect two parallel lines, then each pair of alternate interior angles are equal. We are taking a line AB and which is parallel to CD, a transversal PS intersect AB at Q and CD at R. RTP required to prove angle BQR is equal to angle QRC. This one and this. Second one is angle AQR is equal to QRD. This one and this one. We have to show these two pair of angles are equal and prove AB and CD are two parallel lines and PS is transversal intersect at Q and R. PQA and QRC, these two are the corresponding angles are equal from the axiom 1, and PQA is equal to BQR. These two are vertically opposite angles. These two are the vertically opposite angles from 1 and 2. PQA is equal to QRC, PQA is equal to BQR, therefore BQR is equal to QRC. So whatever the first one is proved, similarly the second AQR is equal to QRD we can prove. Theorem 2. If a transversal intersect two parallel lines, then each pair of co-interior angles are supplementary. AB line is parallel to CD line. PS is transversal, intersect at B, AB at Q, CD at R. Are required to prove angle AQR plus QRC. These two are supplementary. That means sum is equal to 180 degrees. And BQR, these two, BQR and QRD is equal to 180, and these two are supplementary. Now prove. AB and CD are two parallel lines and PS is transversal intersect at Q and R. Angle AQR and BQR both are sum is equal to 180 degrees, that is equal to 1, because these two are the linear pair. And BQR is equal to QRC since theorem 1 alternate interior angles are equal. From 1 and 2, AQR plus BQR is equal to 180, BQR is equal to QRC, substitute in place of BQR QRC, therefore AQR plus QRC is equal to 180. So first we proved the similarly the second one also angle BQR plus angle QRD is equal to 180 degrees. Another one axiom. If a transversal intersect two lines such that a pair of corresponding angles are equal, then the two lines are parallel to each other. The previously we discussed if a transversal intersect two parallel lines, corresponding angles are equal. Converse of this, if the two corresponding angles are equal, then the lines are the parallel. Line M and line N are two lines and a transversal L intersect at P and Q. Pair of corresponding angles, one is equal to 5. So corresponding angles are equal, therefore the lines are parallel. Line M is parallel to line N. It is symbolically we can M parallel to N. Theorem 3. If a transversal intersects two lines such that a pair of alternate interior angles, then two lines are parallel. AB line, another one is CD line, transversal PS, intersect AB at Q and CD at R, RTP, AB is parallel to CD. Given is alternate angles are equal, that is BQR is equal to QRC. Proof. AB and CD are two parallel lines and PS is transversal intersect at Q and R. From the figure, PQA is equal to BQR. These two are vertically opposite angles and BQR is equal to QRC, which is given, and from 1 and 2 PQA is equal to BQR, which are corresponding angles. PQA is equal to QRC, which are the corresponding angles. If the corresponding angles are equal, then the lines are the parallel. Therefore, AB is parallel to CD. Lines parallel to the same line. Theorem 4. Lines which are parallel to the same line are parallel to each other. Draw the three lines L, M and N such that M is parallel to L and N is parallel to N. Line L, line M, line N. Draw the transversal T and angles LM parallel, therefore these two are corresponding angles are equal. L, N, if these two are the corresponding angles are equal, we are naming 1, 2, 3. So from the figure, 1 is equal to 2 because L, M are parallel. 1 is equal to 3. So corresponding angle axiom, angle 1 is equal to angle 2, angle 2, 1 is equal to angle 3. Therefore, angle 2 is equal to angle 3. So therefore, M is parallel to N. Different ways to prove the two lines are parallel. One, showing a pair of corresponding angles are equal. Second one, showing a pair of alternate interior angles are equal. 3, showing a pair of co-interior angles are supplementary. 1, in a plane showing both lines are perpendicular to the same line. Fifth one, showing both lines are parallel to the third line. So these are the 5 ways to prove given lines are the parallel.